Hello everybody, today I'm going to explain the solution to the second problem of the USACO 2024 December contest in the Silver Division, the problem Deforestation. In this problem, we are given n points on a number line, and we know for each point the position it has. And we also have k intervals, and for each interval we know how many trees we must have at the minimum in the interval. And we want to cut as many trees as possible. Or in other words, we want to cut as many trees as possible while satisfying all of the restrictions. And in other words, this can be expressed as keeping as few trees as possible, something you will see that I will extensively use during the problem. The first thing you can observe while reading the statement is the fact that this is supposedly happening in a place called the red-black tree forest. And that actually red-black forest. And while this may seem random and without any sort of, let's say, link to anything we are doing, you need to know that sets in C++ are based on a data structure coincidentally called red-black tree. So in a way, you can think that this is actually even as a hint, or it may be just a random fact that doesn't help us. But it turns out that it can actually be seen as a hint they gave from the statement. And I'm not sure about the other programming languages, but red-black trees are used for such data structures in various languages. And also another thing we want to observe is that in these kind of problems, we want to start off by sorting all of the points as well as all of the intervals. While we don't know yet how to sort the intervals, we can probably guess that it will be either in increasing order of the left end or in the increasing order of the right end. And we also have various subtasks where we know that either restrictions are very small, or also there is a subtask in the inputs 6 and 7 where the value of the I is always 1 for all values from 1 to k. Now, how do we start as far as approaching this problem goes? So now when we look at the points in the number line, so we have 1, 2, 4, 6, 7, 8, and 10. Now we want to know that the intervals we use will have at least the given amount of trees. So for example, if we look at the interval 2, 9, we know according to the sample that it must have at least 3 valid points, like you see here. And now when you think about it, we need to chop some of the trees to at least keep 3 trees around. And when we also look at other intervals, which we might have, so in this one we need 3 intervals, we can have many other intervals. We can even have something like this, or even something like that, but these don't show up in the sample. However, another interval that will show up in the third sample is the 110 interval, where we must have at least 1 tree. Now, when we look at it, some of the strategies which can be used for such problems are to either take trees that are as early as possible or take trees that are as late as possible. And for this kind of problems, greedy approaches can be motivated by the fact that when you look at it, we have the points, the intervals, and if you've ever seen the interval scheduling problem, it makes some sense to think at an approach that's based on these lines. And this is actually one of the first ideas I came up with when I saw the problem, which was to actually sort the intervals in increasing order of the right end, so exactly like in interval scheduling. And whenever I hit the end of an interval, I would apply the following algorithm. So at first, I know that this end is here, and I would add in a multiset all of the trees that are to the left of this end. even if there was a tree here right at the end, I would have added it. And we want to be able to find two things. So we want to first see how many trees we already added in our set, as well as how many trees we still need to add to fulfill the restriction for the given interval. And when we look at it, for both of these restrictions, we can use either a multiset or, as you will see in the code I will share you, even a policy-based data structure, an ordered set, which can be found very easily on a Codeforces blog I will share in the description. Now, when I am at this interval, what I do is to use one of the data structures I mentioned to count how many points are still there, are already taken. And what I want to do is to always take the points that are as much to the right as possible. And the reason I do that is because when you have a point that is to the right, then chances are that you will be able to also use it for other intervals, which is something that you can observe that here for this interval, we can get away by just the 3 points that I mentioned here. And basically, we are done because here we only need one more. We need one more point, and the 3 points we already have are enough as far as this goes. And now, as far as implementing details go, you can observe here that when I did this one, I sorted the points, I sorted the ranges by the second then, and basically I just had more or less an approach where I added the points as they come, and here I use the order set to avoid having to implement anything additional, and I just use the fact that this data structure allows us to find in O of log n how many points are at coordinates smaller than a certain value. And then as long as this is not fulfilled, I just take the rightmost points, and thankfully I have the multiset with the untaken values, which can allow the operation of finding the rightmost point. And after that, I just add up the size of the set. Obviously, if there are points at the end which weren't considered, we also add them to the answer because they can be cut without any issues. And as you can see, the solution is actually rather short. And after you observe the fact that we can do it in a very similar way to the interval scheduling problem, things become much easier. If you enjoyed watching this video, please like the video, subscribe to the channel, and also if you have any feedback, I would be delighted to hear it in the comments. Also, if you or people you know are interested in other USACO videos, or also in ways to more closely collaborate with me or to work with me towards your USACO improvement, please check out the links in the descriptions for ways to contact me, and in general for any kind of feedback you might seek. Until the next time, please watch the other videos as well. I explain the problems from bronze, silver, and gold division, and I hope you have a very pleasant holiday season, and good luck in the next USACO contest. See you. Cheers.